Hello everyone, welcome back to my channel. I'm Ritu and today's video is about learning a handful of tricks to answer a particular type of question that often makes us nervous in any competitive examination. The topic is counting the total number of triangles in a complex figure. So let's get started. Type 1 is counting triangles within quadrilaterals. Here we have a rectangle with its two diagonals crisscrossing one another. The total number of small triangles that we find here are 1, 2, 3 and 4. Now let's take one diagonal at a time and count the triangles. 2. Let's take the other diagonal and it makes 2 triangles again. So the total number of big triangles are 2 plus 2, 4. Now the total number of triangles that we have in the first figure is 4 plus 4, 8. So the formula to determine the total number of triangles in such type of figures is just 2 into the number of small triangles. Here the number of small triangles is 4. So the formula says we just have to double it. So 2 into 4 is equal to 8. 8 is the total number of triangles in this type of figure. Let's look at a similar type of figure. In this figure, we will count the small triangles of the two rectangles one after another. Let's take the bigger rectangle first. So the small triangles are 1, 2, 3, 4, 5, 6, 7, 8. 8 small triangles in the bigger rectangle. So according to the formula, total number of triangles in the bigger rectangle is 16. Now let's take the smaller rectangle. It has in 8 small triangles. So, according to the formula, the smaller rectangle also has 16 total triangles. So, in the entire figure, we have total 32 triangles. Can you just believe? Now, let's go on to the type 2. In type 2, we have triangles with complications planted inside it. So, the total number of triangles here are the total number of smaller triangles plus the original one. So the total number of small triangles are 1 and 2 and the original triangle itself, so 2 plus 1, 3. So if we assume n to be the number of small triangles, the formula comes down to n into n plus 1 by 2. In this case, n is 2 since there are only 2 small triangles, so 2 into 3 by 2, it's 3. Let's look at a similar type of figure. The number of small triangles here are 1, 2, 3 and 4. N equals to 4. And with the help of the formula, we can find out the total number of triangles inside this figure. So it's 4 into 5 by 2, 10. Time for type 3. In this figure, when we try to check horizontally, we find 2 triangles. First is the small one, and the next is the larger one. First, let's count the total number of triangles in the smaller one. It's just the 2 triangles, the 2 smaller triangles inside it and the original triangle itself. So it's 2 plus 1, 3. Now let's look at the bigger original triangle. So it's again 2 small triangles and the original triangle itself. So the total number of triangles in the larger triangle is also 3. 3 plus 3 is equal to 6. And 6 is the total number of triangle in this particular figure. If we take n to be the vertical divisions and m to be the horizontal divisions, find out the total number of triangles in such type of figure, the formula is m into n plus 1 by 2. To know the horizontal divisions, we just have to take the number of bases that we find in the figure, 1 and 2. So there are 2 horizontal divisions, and vertical divisions, as we have just learned from the previous types, it's 1 and 2. So m equals to 2, n equals to 2, and we get 2 into 2 into 3 by 2. How much is it? 6 again. Let's look at a similar type of figure. In this case, we have how many horizontal divisions? Let's count. 1, 2, 3. Since there are 3 bases, so m equals to 3. How many vertical divisions do we have? 1, 2, 3, 4. So n equals to 4. So according to the formula, the total number of triangles in this particular figure is 3 into 4 into 4 plus 1 by 2. It's 30. Now let's go to type 4. In this type, we'll find different number of triangles embedded within the original one. So the total number of figures in this figure is the original one, which is the transparent one, plus the smaller triangles in the original triangle, that is 1, 2 and 3 smaller triangles in the original triangle, plus the number of embedded triangles. Here in this case we just have 1. The formula says, if we assume n to be the number of embedded triangles within the original one, the formula comes down to 4n plus 1. So in this scenario, we have just one embedded triangle. So 4 into 1 plus 1 is equal to 5. Let's look at a similar type of figure again. In this case, how many embedded triangles do we have? It's 2. This is the first one and this is the second one. So according to the formula, the total number of triangles in this particular figure is 9. Since 4n plus 1, here the value of n is 2. So 4 into 2 plus 1, 9. Last type for today, type number 5. In this type, we will have several triangles inside the original triangle set in triangular ways. Now, if we count the number of triangles in this figure manually, we will find that there are total 13 triangles in this figure. In this type of figure, we just have to count the number of unit triangles by the side of the figure. And the formula is n into n plus 2 into 2n plus 1 by 8. By the term unit triangles by the side of the figure, as you can see, I have marked 1, 2 and 3. So in this case, we have 3 unit triangles in this figure. So when we put 3 in place of n in the formula, we get 3 into 5 into 7 divided by 8, which is equal to 13 approximately. It will come around as 13.2, but we have to just ignore the decimal part. We'll just have to take the 13. Hope all these tricks will help you score higher in your competitive exams. This topic was requested by one of my subscribers. So if any one of you want me to make a video on any mathematical topic, please let me know in the comment section below. And don't forget to like, share and subscribe to my channel. Till next time, bye.